1. Yeah, a linear equation gives you one solution. If you write that single variable linear equation as its related function with an x and a y, and you graph it, you'll get a line because it's linear, and that x is going to be where your line crosses the x-axis. Okay? And that's because when you're solving for x, because there's not a y there, basically what you're saying is y equals 0. Huh? If you only have an x, well, you could say there's a y, but y equals 0, and y equals 0 means you have an x-intercept. That's a special point. So when you solve a single variable equation, no matter what degree, any x you get is going to be an x-intercept of the related function. Okay? So let's rewrite. Let's say y equals 0. We already are solved for 0. If you're not already solved for 0, you have to do that first. So if we say y equals 0, then that means 0 equals y. So let's rewrite this as x squared plus 4x minus 12 equals y. Okay? Now, how many solutions do we have here for the single variable? 2. Okay? Now that if we took away that y equals 0 and said, no, we do have a y, so let's go back to having a y instead of 0, we have 2 variables. How many solutions do we have now?
2.
How many points are on a line? How many points are on a parabola? You plug in an x, you get a y. Okay, now plug in a different x. Okay, now plug in a different x. This is going to generate, remember, this is a function. It generates ordered pairs. How many ordered pairs will it generate? Infinite. You put all those points on a graph, connect the dots, you have your function. You have your graph of your function. Okay? So when you have y equals 0, that's going to give you 2 very specific points. But if you just go back to y and say y could be anything now, you've got infinite points that create a graph. 2 variables has infinite ordered pair solutions that create a graph. Okay? So let me just turn it around because it's easier for the eye to look at. Y equals x squared plus 4x minus 12. Okay? And we can even then write it in function notation. If you can solve for y, and we know a parabola is a function, we'll write it as f of x equals x squared plus 4x minus 12. Okay? Either way, this means you plug in an x, and the value of the function then will be some other number. Plug in a different x, you get a different y, or a different value of x. Okay? So a different value of the function, and so forth. And you graph these, and because this is second degree, you know you're going to get a parabola. And how many times does a parabola cross the x-axis? 2. Yeah. Generally, 2 times. It comes down through it, and then comes back up through it again. Where do you think it's going to cross the x-axis, this particular one? Yeah. So let's look at that. Enter the function, the 2 variable function. It's already solved for y. So just enter x squared plus 4x minus 12. Now let me look at my window before I graph it. So my window, I don't have a standard window right now. You can always change the window manually, however you want your biggest x and biggest y, biggest and smallest x and your biggest and smallest y, yx, y min, y max, and x min, x max. Okay? But you can also just go to standard if you go to zoom and either do 5 for square, which makes it more proportional, or z for standard. Okay? Don't push, when you do that, don't push enter. It locks my calculator up. I don't know if that happens to everyone, but it does to me. If you do one of the first ones, 1 through 4, then you do push enter after you push the number. So I'm going to put it as a square, so I'm going to choose 5, but I'm not going to push enter. Okay. Actually, I need to go back to standard because I am zoomed in here too, so I kind of got mine mixed up earlier. So let me do standard 6. Okay, there we go. So there's the standard screen. Okay. So here's a parabola. We can't see the bottom point of it, but it comes down and turns around. Okay? Where does it cross the x-axis?
-6, 0, 2.
Good, and in ordered pairs specifically. It crosses at those points at -6 and 2, but most properly, remember, intercepts are written as ordered pairs because they are a point. So to solve this, we said y is 0, okay? Which means that we have 2 points here. As ordered pairs, our x-intercepts are so this is set notation saying this is just a list of the x's. Okay, set notation means a list. This is not an ordered pair. -6, 2 is not on this graph. Just we got one of our x's is -6 and the other x is 2. But when we're talking about the related function, we can write it as ordered pairs each x gets y equals 0, and there's the two ordered pairs that are the x-intercepts of the actual graph. Huh? Understanding this is going to help you graph all different kinds of families of functions in college algebra. Okay? Quadratic families, cubic families, other families besides that. Okay? You know their x-intercept. You can solve the related equation. You know x-intercepts, and you know how to start graphing it. Okay with that? Okay. Some of that is understand there's a couple questions on homework that ask you to, that gives you a factored function and say, which graph matches this. Well, if you can see the function itself and it's factored, then you know what its x-intercepts are going to be, and so you can identify the graph. Okay, I'm not asking you to hand graph them yourself, but you need to be able to identify which graph goes with a certain function because you can see what the x-intercepts are by solving it, by factoring it. Okay? So just having that understanding right now, like I said, that'll be developed further in college algebra. Okay, so let's do a couple more variations on the equations. Okay. Say, for example, x times 3x plus 14. Okay. Now, I haven't written the equal yet, but is there anything to if this was all I had, if this is equal to 0, am I already factored, or do I have some more factoring work to do?
You're already factored.
Yeah. I mean, what degree is this?
Squared.
Yeah. Yeah, even though you don't see a square, if you distribute this becomes 3x squared, right? So it is quadratic, it's just already been factored. So you're like, oh, maybe my work's already been done for me, okay? If it were equal to 0, then yeah, your work would already be done for you. You just set x equal to 0 and 3x plus 14 equal to 0, because you're already factored, if this is equal to 0. But this is not equal to 0, it's equal to -8. Okay? So if your eye goes, oh, already factored, good, x equals 0, x equals -14/3, no. Not if this isn't equal to 0, because you left some guys sitting on the lawn, and that's really rude. Okay? Everybody has to be invited into the party. Then break up the groups, because it'd be rude for them to come in and then just have to stand in the corner. Okay? Break up the groups, invite them in, then regroup. Okay? So, if this is not equal to 0, any parentheses or fractions, in this case parentheses, break them up. If this were equal to 0, it's okay, keep the parentheses, you're good. Okay? But nope, you're not ready to factor yet, so anything that's already factored must be unfactored.
So would you put 3x squared?
Yes. Plus,
Plus 14 minus...
equal, yeah. I'm just going to do that first. I broke up groups. Okay? And then I have to put, the next step, I have to put it in standard form. I'm not going to make any other decisions. If you start, oh, I can factor an x out of here. No, they've just been going backwards.
So you're going to add?
Yeah. A lot of people at this point want to start factoring. Because you see a GCF, your eye sees a GCF. No, not until you are in standard form. You cannot start factoring, making any factoring decisions, even GCF, until you're in standard form. Okay? So invite him over. Okay? If the way I can write +8 under each thing, and feel free to do that. That's your addition property. +8 will make it 0 over here, and then add 8 here. Remember, whatever you put over here may or may not be a like term here. Anything that's a like term you can combine. You want to simplify your like terms, but don't simplify things that aren't like terms.
You can't, right?
Right. This is not a like term with anything here. Remember, a like term has the same variable, the x, and the same exponent. Okay? So anything you invite over, if you can combine it as a like term, then do. But don't try and smush together things that don't belong.
So if that was a -8x, then you could combine it, right?
Yes, exactly. Yes. If this were -8x, we'd be adding 8x to this side, and then we could combine these two and get 22x.
Why don't you do that on the second step?
On,
Like, instead of doing that third one, why don't you just do 3x plus 14x, and you already know that's negative, so you positive 8 and then equal to 0.
that,
Because those are not
Yeah.
like terms, right?
so why didn't I put this together, you mean?
She
Or?
was saying, like, why didn't you do the work on the other step before?
Yeah, like, do 2 things in one.
Because of the 9.
Oh, you could have brought this over first and then, or brought,
No.
or,
No,
She was saying doing everything together in that
Yeah,
one
like
step.
skipping the second so you did just write out third.
Like mentally.
Yeah.
oh, absolutely, oh, yeah. The more, yes, right now for demonstration, I want you to see that these are clear steps, so you, because the order matters. But yes, they're absolutely, yes. And in fact, at this point, that's what I do. I go ahead and distribute this, and I go ahead and bring this guy over. So I would go from here to here.
Yes.
Yes, because I'm used to, yeah, I can take care of that and go, oh, okay, let's go ahead and bring him over while I'm at it.
Yeah.
Absolutely, yeah. Yeah, if you don't show me this step, that's fine, as long as you know you are still comfortable with what you're doing, you get to the right answer. Okay? I want to see your work. That doesn't mean you have to show every step once you get good rhythms and strategies and mental comfort with it. Yeah. Okay, so I am equal to 0 now. Everybody's at the party. We're ready to regroup. And now is when you factor completely, and now is when you rely on all your factoring skills. Is there a GCF? No. It is a quadratic trinomial, so there's no GCF. If there were, I'd take it out. There's no GCF, so I'm ready to say 4 terms, 3 terms, or 2. There's 3 terms. Quadratic trinomial. A is not equal to 1. It means I need to factor it in 2 steps. Okay? Now, like I said, I want to show you a couple examples and so on. I want you to try this. So I'm not going to show all this work right now. If you're uncomfortable factoring this, okay, that means, oh, I need to practice this one.
So you
Okay?
bring the 3 out, right?
Well, no, because it's not a GCF. There's no GCF in this one. Okay? You do have to use, I'll just real quick show you, do have to use your ACB. AC is 3 times 8, positive 24. My B is positive 14. So my magic pair of numbers is 2 and 12. Because 2 times 12 makes 24, and 2 plus 12 equals 14. My sign pattern is plus plus, so everything's positive. Now, if A is not equal to 1, I am not done. When A is 1, you are done, and the magic numbers are your constants. When A is not equal to 1, you are not done. Your magic pair of numbers is your split middle. My middle variable is x, so each of these gets an x, and I rewrite as 3x squared plus 2x plus 12x. Both of them are positive. It doesn't matter what order they go in. Remember, if you can keep a positive in the middle, do, because the order you put them in doesn't matter. If you can't, you got a subtraction in the middle, that's fine. Just remember, you have to do your sign flip, because now you're doing 4-term grouping. Plus 14, plus 8. Plus 8 equals 0. Keep bringing that equals 0 along. This is not just an expression, it's an equation.
Then you can combine, right?
Yes. Now when I do my grouping, my 4-term grouping, do your little GCF, little GCF, little GCF, and you end up with 3x plus 2 times x plus 4 equal to 0. Okay? So identified what I had, checked for GCF first, saw it's an A not equal to 1 trinomial. I did my ACB in my grouping because that's what A not equal to 1 trinomials require. I still have the equal to 0 on the side. I'm bringing it along. Do my grouping. When I finish my grouping, I have these 2 binomials. Okay? And so that means my solutions are, and I was expecting 2 because this is quadratic. I got 2 linear factors. Each linear factor gives me a linear equation by the 0 factor property. And each linear equation then gives me a solution. So 3x equals negative 2, x equals negative 2/3. Your fractions, your solutions might be any real number. That means they could be 0, positive numbers, negative numbers, fractions. Remember, always write fractions. Please don't write decimals. Lowest term fractions equals negative 4. So I've got, and it's good form to put your set in order, but it is not required. Using braces set notation does not require an order, though it looks nice to the brain. Okay? Now I'm going to speed ahead because I want to show you a couple varieties so you feel confident then doing the practice yourself. Okay? But I cannot emphasize enough, we are going back and back and back to this order. Okay? And then once you do these first 2 things and make note of your degree, your expectations, then it's all about the skills. It's all about the factoring. Okay? So you take a breath, you remember your factoring order of things, GCF first, count your terms, what do you have left, how do you know you're done?
Okay, just to refresh it real quick.
Mm-hmm.
Okay, if we couldn't get the small GCF out of the 2 binomials,
Mm-hmm.
do we just keep, the answer would have been those 2 binomials in the parentheses, right? And there would have been like no common.
When you're doing ACB with a trinomial, and A is not equal to 1, so you have 2 steps, it is true, if you're just given a 4-term polynomial, it's not always factorable. You won't always be able to do the grouping method. But if you are doing the grouping method because it's the second step of factoring this trinomial, it will work.
Oh, so
It will work.
the first,
Yeah. You will. If you have an A not equal to 1 trinomial and you do have a magic pair of numbers, you will be able to group. You will get 2 binomials,
Okay,
period.
and you will be able
Yes,
to
yeah.
equal it to 0.
Not every 4-term polynomial is factorable, but every 4-term polynomial you get from as the second step of this method from a trinomial is. Yeah, because you designed it to work. You chose the right number. If it doesn't work, maybe you chose the wrong numbers.
Or
Yeah, yeah.
maybe the answer would be.
The answer is going to be 2 binomials, yeah. And if you can't get it to group, either you made a mistake in your little GCFs or you made a mistake in your magic numbers. Yeah. You will be able to group it. Yeah. X cubed minus 49x, and this one is r equal to 0. Note that I could have given it to you like this. I could have given it to you as x cubed equals positive 49x. That one for some reason looks really confusing because like there's just one term on each side. Okay? But look, all that happens is subtract 49x from both sides. Okay? So this is positive 49x, so I subtract, I do the opposite over here, and that canceled it out to 0. Okay, so whether you're given this or this, now you're ready to go. But if you're given this, you have to make it look like this first, and now you're ready to go. Okay? So before I start factoring, and I'm ready to do so because everyone's at the party, what's my expectation? How many linear factors will I get? 3, and each one will give me a solution. Okay? So now I start factoring. My first thought in factoring, right? How many factors do I have on the left now? 2. I'm expecting 3. I only have 2. On top of that, are they? Which one's not linear? Yeah, that's a linear x. That is a linear factor. It's just an x. It's not a binomial, but that's a linear factor. It's got an exponent of 1. So we're done with it. And here, though, we can say, oh, wait, I'm expecting 3. Also, this is still quadratic, so this should give me 2 more. I should be able to break it down further to 2 linear factors. Okay, so what do I have left here? I've got a binomial, right? Okay, so it's either a sum or difference of squares or a sum of difference or cubes, if I can factor it. Huh? Is it? Yeah. Difference of perfect squares. You want to be able to, difference of squares is a factor, like some factoring you use a lot and some you know how to do it, but you don't use it a lot. Difference of squares you should be able to do in your sleep. It's a factoring you do a lot, you use in a lot of contexts. Okay? So x plus 7, x minus 7. Okay? Difference of squares factors to its conjugates. There's my 3 linear factors. Now remember, if you had pulled out a GCF that was not an x, say you just put, instead of having an extra x, there was another, like a numerical GCF, and you just pulled out a 2. Okay? Then remember I said that it's only variable factors that count, because if let's say this was a 2 instead of an x, that whatever we had, we got down to 2 here. So we would set 2 equal to 0. Does that make sense? Now remember, when we get something like that when we solve an equation, that means no solution, because it's false. Okay? Now that doesn't mean anything's wrong with the rest of the equation, it just means that's not a solution. Okay? That's why numerical factors don't count as part of your degree or your number of solutions, because they don't give you a solution. You have to have an x to have a solution. So numerical factors are important, you have to pull them out, but if you're doing an equation, you don't need them anymore. If it's just a number, it's not going to give you a solution. But here, our GCF was a variable factor, so that's one of our solutions, and there's nothing else to do with it. Even if it had a coefficient, it's still going to be equal to 0. Even if it had like 5x, it would still be equal to 0. You divide 5, it's still 0. Divided by anything is still 0. And then the other solutions is x plus 7 equals 0, or x equals negative 7, or x minus 7 equals 0, so x equals positive 7. Now this is a cubic. A cubic does not make a parabola. Okay? This, I'll call that negative 7, and that's 7. Of course, that's 0. So this would be, a cubic makes kind of a roller coaster shape, like a swoop. Okay? And so how many x-intercepts does it have? 3. Its degree is 3. It has 3 x-intercepts. When you solve its single variable equation version, you get 3 x's, 3 solutions. And the 3 x-intercepts of this cubic equation are, and the origin, and, yeah. Yes, when you're solving, this is just so you're understanding sort of the concept, why we're doing, and for that, and you may be asked, what are the x-intercepts? And if you're asked for an intercept, you do put it in ordered pair form. Whenever you're just told solve this equation, list the solutions. These are just x's without the y equals 0. You're listing your solutions, so you use braces because it's just a list. -7, 0, +7. So that's what you would tell me. This is more just so you understand what's the point. Where is it taking us?
But if I was to put that, would I still get credit for it, or would you not count it right? Like if I would put everything in parentheses, -7?
Yeah, because you're solving a single variable equation, then put your answer in set notation. The directions will say specifically put your answer in set notation. Now, I may ask a question, and I may ask it as a bonus, what would be, tell me the x-intercepts for the related function. In that case, you would, if I say solve the single variable equation, use set notation, you use that. If I say what are the x-intercepts of the related function, then you have to write it in ordered pair form with the y equals 0. Okay? So read the directions carefully, and I'm happy to clarify. I hope you understand those two things. This is the focus right now. This is planting the seed so you understand why we're doing it and how you're going to move further with it. Okay. So let me do a fraction one, and we'll look at a word problem or two. Bless you. Okay. So x squared over 20 minus x over 4 is equal to -1/5. Now, a lot of people do, but our job is to kill the fractions. Okay? So we're going to flatten it out, just like, this is the first step, just like us solving linear equations, which are polynomial equations too. You're not ready to solve it yet, you just got to clean it up. Okay? So any fractions, you're going to kill them. You need your LCD, which is, good? It's always the biggest one or bigger. Now, you have 3 terms, okay? All of them are fraction terms, but whether they were all fraction terms or not, if there are 3 terms, every term gets multiplied by 20 or 20 over 1. Okay? So just because these are all 3 fractions doesn't mean you won't get one where one's not a fraction. You have to be fair to every term. All right, so 20 over 1, 20 over 1. We're multiplying by the LCD over 1. Okay? So here, the 20 cancels out, leaves nothing behind, right? Here, the denominator, remember, it's always physically striking out. This was something we had a lot of problems with on the test. Make sure you are reviewing and understand how to do this, and reflect on that test and let me know if you need extra help with this. These both cancel out, but because they don't match, what's left behind on top? 5. And remember, this is multiplication, so it'll be 5 times whatever's there. Yeah. And here, 5 and 20 cancel out. What's left behind? Yeah. Times, and this is being -1 that's left behind. Okay. So now it's flattened out. We've got an x squared minus 5x equals -4, because it was a -1/5. Okay. And now move forward from there. X squared minus 5x plus 4. Everybody gets invited into the party. The lawn is empty. Evaluate what? Okay, I'm ready to factor. You go through your Where do I start? GCF? Not 1. Okay. I've got an a equal 1 trinomial. I identify what I have. I know I use my ACB. A equals 1, ACB, and you're done. My sign pattern will be double negatives, so that'll be 4 and 1. Okay. And of course, so you use your ACB, X, whatever you need to get there. Okay. That was the quick mental version. The more you can do these A equal 1s mentally, these are ones that are never going away either, like difference of squares. So the more efficient you can get, especially with the A not equal to 1s are just tedious. Okay. But A equal 1s, the more you can do those mentally, the smoother things go. Okay. So we've got 2 factors as expected. 2 linear factors give us 2 linear equations by the 0 factor property, giving us a +4 and a +1. This would make a parabola. It's in the parabolic family, quadratic family. It makes a parabola, so it would be a parabola that crosses at both 4 and 1 on the x-axis. You just have to say my x's are 4 and 1, or 1, 4. Order doesn't matter, but yeah. But if you were to draw the related parabola, it would be a parabola that goes down through +1 and then up through +4. Okay. Now, one quick exception, then I'm going to do a couple word problems. I want to give you as much time to practice as I can. I just want to make a point. A couple things you might see And I'm not going to solve these completely, but I just want to point out some other things you might look for, so it's not a total surprise, okay? All these rules are really set. You know everything to do. If you get stuck, panic, take a breath. You have all the steps in the order you need to use them, okay? All of these, everything I give you will work with these steps and these factoring skills. You may be given something like this: x cubed plus 4x squared equals 9x plus 36. I've got two things to move over here. Okay? So x cubed plus 4x squared minus 9x minus 36. We'll leave 0 over here. Now check before you move on. Do I have any like terms? Sometimes you will. When you move things over, you might end up, you got to put your like terms together first. I didn't really include that in the list of steps, but basically that's the cleanup. You don't know how many terms you have to factor with until you have the minimum number of terms. So if anything was a like term, you put it together. Okay? These are unlike terms. Remember, if they have different exponents, you can't smush them together. So you've got 4 terms over here. Okay? So you're going to use what method? Grouping, right? For some reason, a lot of people look at this to begin with and it's like, where do I even start with that? Same way you start with everything. Okay? No fractions or parentheses, good. You put everything in standard form, good. Make sure it's all cleaned up. Okay, count my terms. Well, there's no overall GCF, right? Count my terms, 4 terms, I group. And that's going to give you a binomial times a binomial. Okay? But here's the trick. How many solutions are you expecting? 3. Okay? When you group this, and don't forget, this has to become x cubed plus 4x squared plus negative 9x minus 36, so that the negative 36 doesn't change, but now you've got a plus in the middle. Be careful. A lot of people are careless about this. Make sure when you do your grouping, you have a free-floating plus in the middle. If you don't include that, it looks like you've got 2 binomials multiplied already. Don't do that. Okay? So when you factor this dot, 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 now, and remember this is a negative GCF, so this will be negative 9, and this will be x squared. Okay? So when you finish the grouping method on this, you end up with x squared minus 9, and you end up with x plus 4.
But why did you do x squared? Can I ask that question?
Because that's the GCF of this first group. They have 2 x's in common. So x squared gets GCF'd out, okay? And then minus 9 gives us 1, and then what's going to be left behind in each one is x plus 4. That was our big GCF. Okay. So you'll get from, your 4-term grouping, fix your sign, negative GCF, finish grouping, you get this. How many solutions did I expect?
3.
How many do I have? 2. Am I all linear? What's not linear? Can I keep going?
Yes.
What does this become?
X.
Yeah. This is conjugates. Difference of squares, factors to conjugates. And we still have the x plus 4. Now we've got 3 linear factors. There's our 3 solutions. Okay. And the other sort of thing too, so you may encounter that. See, that was nothing you don't know how to do. Okay? You've just got to keep thinking through the process. What's the order of my steps? Keep thinking through the process. Don't panic and get choked up. Panic releases these chemicals in your brain that just shut things down. Everything I give you is a skill you know how to do. You just have to breathe and remember the steps in the order. Okay? I'm not going to give you, things might look a little different, but they're all going to be the things you already know how to do. And you also might see it with a quadratic, you expect. Let's say you have whatever problem, whatever you started with, okay? And when you ended up factoring it, your factored form was a binomial squared. Okay, so you had a perfect square trinomial you had to factor. Okay? So starting with some perfect square trinomial, which obviously would have been x squared plus 6x plus 9. Okay? And it factors into a binomial squared. Okay? Now, you expected 2 answers, right? Well, this is a binomial squared.